I always plot the same values. I start at 0, 0, because what's the square root of 0? What's 0 times 1? Okay. After that, I go to my next perfect square. My next perfect square is positive 1. Square root of 1. 1 times 1.
1.
The next perfect square. 4. Square root of 4. 2 times 1. And this is my, what we call the parent function. From that, we always graph the parent function as a dotted line. Now I shift all 3 of those points.
They just didn't give us room.
Yeah, that's not the end of the world. When you go to shift this, everything's got to move to the right 7 spots.
Oh.
And they did give you room if you realize it was counted by 2s.
Oh, was it real? Dang it. Oh, no.
So now when you go to shift everything out, here's 4, 5, 6, 7, 8, 1, and the other one would have been, what was it up here? And then that becomes solid. And that's your shifted graph. The shifted graph always goes with a solid line. The other one is a dotted. Okay. Yes,
The
ma'am.
third point, is that 4, 2?
To start with, yes.
Yeah.
Mhm. Yes, sir.
What's going on with the test tomorrow? Is there going to be a calculator?
Not completely finished with it, but I'm starting to lean towards that. The non-calculator will probably be a graph.
Just stickers?
Yeah, because I don't know if the other stuff I can make it non-calculator without having to worry about it being calculator. No worries. It did make sense. In my brain, it did make sense.
I'm worried though, because that race has the grade going down.
Yeah.
What else do I look on graphs?
That's no worry. What about the...
Oh, okay, great. Domain. In this case here, remember when I go and look for my domain, I always look at my shifted graph. What is the smallest value of x for my shifted graph? 7. So my domain is going to be x is greater than or equal to 7. For my range, I'm looking for what is the smallest value of y? 0. And since my graph is moving upward, it's going to be y is going to be greater than or equal to 0. Those are your domains and ranges. You don't have to worry about domain and range when you're dealing with the cube root function because it's continuous.
Oh, which one?
Yeah.
You do 2x. 130.
Oh, number 18? What most people forget on this, what has the x going? Just the x. The x value here is the only thing that has the
Oh, so
cube
it's
root.
just like 2.
So it's 2
x root.
cube root of x minus 3. That's the only value that has the cube root to it.
So that's like the same.
Yeah. So now when you graph a cube root function, you do the same steps. Your a value is 2. Here my h value is 0. And my k value is negative 3. When I start to sketch cube root function, I use my y equals 2 cube root of x, and I pick some perfect cube roots. 0. I have 0. I use 1. Cube root of 1 is 1. 1 times 2 is 2. And then I have the negative 1, and I get negative 2. And all of my cube root functions all look the same. They've got kind of like an S to them. Like that. Yeah.
The one with 0, wouldn't that end up being negative 3?
Yeah.
Because cube is 0, 0, 2 times 7.
I haven't shifted yet. This is
Oh.
just my parent function. Remember, I always graph my parent function prior to the shift. But you are correct. Now my shifted version of this would be at, everything's got to move down 3 spots. So it's at 3. This would be at, what was that? Negative 5. This would be at 1, 2, at 0. Oops, did I mess that up here? Oh, sorry, negative 1. And I make a solid. And there's my shift. Make sure you graph both parent and shift. Any other graphs? Yeah, remember, domain and range in here I don't have to worry about. It's going to be all real numbers because it does not stop. Okay, we are open for questions. What do we got? Yes?
At the top of that chapter testing we have to do, how would you do one at the test without a calculator? It said like 125 to -3.4. So it would just be -5?
That's it.
Easy enough. And then what about the -7 to the
Negative which?
27?
All right, negative 27 to the 2/3. When you look at that, remember what the denominator means. The denominator means cube root. Do you agree? What's the cube root of negative 27? What's negative 3 squared? Okay? And that's about as difficult as that would be.
So like, are those something you put on your 9?
That would be as difficult as it would be, yes. Okay, here, I'll get you next. Same side?
Yeah.
Want to wait? Want to wait? Number 7. We have 4x y to the -1 over 16xy squared. When you have a value like this, we always start out the same way. We always start with numbers first. 4 over 16 simplifies to 1/4. The next, I go to my each variable. X over x, those guys drop out, becomes 1. Now I've got y to the -1 and y squared. That -1's not happy, is it? So if I drop that down, I get y squared y, which becomes 1 over 4y to the 3rd.
Alright, that's no problem.
Okay?
So the x is just gone?
Yeah, this is x divided by x. Which
Would
gives
it
you
still be 1x in there?
No.
It'll just be 1.
Think about your exponent rules. Who wins the game of war? The draw. What's one? They drop out.
They get scared.
They're the French.
So it does no remaining.
Thank you, history. Thank you. They run away.
Okay, so it's
I
Yes.
surrendered one battle, and everyone says I'm surrendering.
Well,
Like,
come
one
on.
in a million
So
battles.
what? It's
They were
just-
the greatest armies of all time.
Well, yeah. I know Napoleon. You know, that's where the short man complex comes from. He's like, I'm going to get you.
Reminds me of Mediterranean.
That was a good impression, wasn't it?
It's not really
No.
Here's Napoleon dying.
the one from Florida.
It's kind of the same impression. Or you can help me.
You're scared.
Number 5.
Which one? There's like 3 of them.
Oh, yeah. Yeah.
Also, if you guys want to take out your quiz, I'll answer some of those too.
Oh, because
Yeah,
we weren't
keeping
our
No.
Oh, that's right. She was the last one. I'll get those back to you in a minute here. Sorry about that. Now, there's a couple of things you can go about doing this problem. One thing that I recognize right away is, notice how I've got the same exact exponents on the interior, but I have different bases. So I really can't do anything here. But I've got power to power, though, don't I? What happens was when you distribute that in here, you get 1/3 times 3, 1/3 times 3, which gives you 3 times 4, otherwise known as 12.
That's what I thought.
Yeah, and that's right.
And then you have to keep going number 6.
Stop. I'm sorry, I didn't skip over you. No, it's going to be negative. It's going to be, yeah, oh, yes. 1 over 5. Yes. Sorry, I was thinking of the different one that was like that. All right. What else we got, guys?
Number 8.
When you have the square root of 98 plus the square root of 2,
It's 100.
it's not going to be the square root of 100. And the reason is, if you look at it, in order to add those guys together, you have to have the same root base. Well, the square root of 98 can be rewritten as the square root of 49 times the square root of 2. Do you agree? Square root of 49 times the square root of 2 is the square root of 98. So what is the square root of 49? Again, what we're looking at here, guys, is the square root of 98 plus the square root of 2. I can break this down to the square root of 49 times the square root of 2. It's 8 root 2. You have to simplify the radical prior to adding them together.
Can we work on some function stuff?
Yeah, which one?
Well,
I was
that one?
on 108.
Look, see,
No, you
I
have to,
think
because you
what
can
it
combine
is
them, because
against
there's a
the-
1.
Oh,
Which one now?
yeah, this one, right?
On the 108 stuff, when you're looking at the function notation, they start to ask you about what the domain and the range is going to be on those. Don't worry so much about finding domain and range on those chapter test B's and C's there. That's something that we're going to reinforce again in chapter 9, believe it or not. We see that a lot more because what they're looking for is domain and range there. Sometimes you can't have certain values in your denominator, so that's why it gets like that. Jackpot. I give a bunch of this stuff back. The kid that keeps on going. So let's look at the function stuff.
This one's wrong.
And number 13, f of g of x. I have f of x is x minus 1, and g of x is 2x. And I want to know what f of g of x is. Which means I write down g of x, and I surround it with the f of x equation without the x value. And I'm done.
Which number is
Do you have the answers to all of the questions?
No, I was supposed to do that, and I forgot to write them all out.
this?
What's that? Not off the top of my head right here. I'll get them. I think I have them right around
Do you
somewhere.
want to give me
Be a minute. What's up?
Oh, can I?
I'm going to go get to the quiz here in a second. I just wanted to go through these things too, because I know there's. I want to do the last problem of the quiz. About this. Okay. Have any of you guys gotten into the stapled packet at all yet? Good. Were the graphs terrible? I mean, I know the one with the 3/4, but it's a halfway point. It's not that bad.
For number 3.
Yes. Thank you. And number 3, 3 and 4 on here, you've got h of x is x squared plus 4x. G of x is x minus 5. And they're asking you what h minus g of negative 5 is. Here's what happens. This is kind of a weird thing, and I don't believe we ever set one up with that kind of nomenclature, the way that it was written here. What this is telling you to do is take the h of x equation and subtract the g of x equation. And then substitute in negative 5 for x. We wouldn't have written it like that. And when I printed, I made this worksheet off some software that we have, and I didn't catch that. The test will not look like this. Okay, the test wouldn't look like that. I will have it written out where what's f of negative 5 minus f, g of negative 5, something along those lines. That makes more sense. Okay,
Then you just substitute the negative 5 into that.
that's 3 on that packet part. The way that because this is written a little bit weird, I would have written it as h of negative 5 minus g of negative 5. I would have done that.
Don't you just?
Yeah, I figured that out after I did it. It took one time, but it said that they got 15, I got -5.
You messed your signs up. When you substitute in, you get negative 5 squared plus 4 times negative 5 minus a negative 5 plus a 5. This becomes 25 plus minus 20 plus 5 plus 5. 5 plus 5 plus 5 is 15. You just missed a sign. When you probably wouldn't see the exponent, you didn't cover it, you didn't close it with parentheses. It's very common. Just make sure when you're squaring something in your calculator, throw parentheses around it. Yes, sir.
If you have an exponent like y0, and then it's like y to the 0, and then it's
surrounded by parentheses, and then root 5, or 5.
What number is it?
5 squared, 16. Is it 0 then, or?
16 on the packet part here, guys. I have y times x to the negative 1 times y to the 0 all to the 5th. What is anything to the 0 power? 1. So that means right now on the interior here I have y over x all to the 5th is y to the 5th, x to the 5th.
So it's gonna just get rid of this, times 1.
Yes. Yeah. They find that cube.
So it's y over x.
No, y to the 5th over x to the 5th.
You can't simplify that anything.
Nope, nothing. You're not solving for anything. Yeah, Morgan.
Can you do number 7 on the quiz?
Sure. Oh, let me get the right file open here. Let me open up the right file here real quick. What is g of negative 1?
No, what is it? What's negative 1? Is that like
No, it's just use negative 1, substitute in. So I have negative 5. Now I take that and I square it and I times it by negative 5 and I get negative 125. You start with,
Why are you using -1 and then you get -5? Why is it?
I'm substituting in this value in for x. So I get negative 5 times negative 1 squared,
Right.
which is negative 5. Now I have to substitute that in again for x, because it's g of negative 1. You take whatever answer it is and you substitute in.
-5 times -1 squared equals -5.
Yeah. What's negative 1 squared?
Oh, okay. I was like, what?
Okay. Yeah.
Can you do 8 on the quiz? Yeah. Say what did you
F of g of x, or g of f of x, excuse me.
8 is the
G of f of x. So I write down the f of x equation, x squared minus 5, and I surround it with the g equation. Okay?
How do you distribute that out? Oh, what? Oh, okay, now I'm lost. What? What did you just do?
Chunk squared.
Oh.
You just killed the puppy.
Wait.
You killed the puppy.
Oh my.
And then distribute out, and that gives you the right result.
That's why I killed him.
Don't kill puppies. Puppies are your
Wait,
friend.
how do we kill him? Oh,
By taking junk squared and just distributing the junk instead of doing junk plus the junk.
So,
12,
12,
That last
for
one.
number,
How about-
for number
so
7.
yeah, the last one, or you know, like 17
For
also.
the 8, is it, would it just be x squared,
Oh,
5 squared?
I've had a lot of questions on 17, so we walk through it real fast. Okay?
Yeah.
That's what I don't know. I'm not sure he's with the 18. I don't know.
Why were you cheating on me? You just
When I
said-
go into the number 17, if I have to take the fourth root of 18 x to the 8th y to the 9th z cubed, that means I have to take the fourth root of each and every single one of those terms. So to start with, is there a perfect fourth root that goes into 18? No, there is not. So it stays in here. Go to the next one. What the shortcut with doing with the nth roots with exponents is 4 goes into 8 how many times? 2. Is there any left over? Take 2 out.
So you,
4 goes into 9 how many times? Is there any left over?
yes.
How many?
1.
So 2 come out, 1 stays in.
What?
Does 4 go into 3?
No.
No, so all of it has to stay in.
Did we learn this?
Yes, we did.
Yeah, we
When?
did. Even I knew.
Why
Why is there?
That's the, I remember if I just put in the leftover and I killed a puppy. Is that what it's called?
No, but the cube root, no, if you're multiplying 2 times the cube root of 5 would be the cube root of 5.
Again, whenever you are working with nth root stuff,
Which is the cube root of 5.
when you're working with nth root stuff, you're taking the fourth root of each piece. And you try to simplify them.
Sending notes.
I cannot find a fourth root of 18, so I just keep that in here.
Yeah, you can't square the cube
The fourth root of 8, the shortcut for that, you can write it as fractional exponents if you want, or
5 is a 2.
4 goes into 8 how many times?
Isn't the same as
Twice. So you can take 2 out. There's no leftover. 4 goes into 9 twice. There's a leftover. There's 1 left over, so 1 has to stay in. 4 doesn't go into 3, so all 3 of them have to stay in. That's the shortcut way of doing that. The long way was to rewrite it as a fractional exponent and simplify your fractions all the way down the line. Which is a pain.
squared times the
Speaking of pains.
fourth root of 18y is equal to the
Yeah.
third. Basically what you have is, I
Okay.
took the 16 out.
The last question on there.
Oh yeah. Because you can't have the radical.
You can't have the radical in the denominator, and that's what most people forgot. So the rule is here, when you're finding your inverse, you have y equals 3x to the 4th. It's telling you that x is going to be greater than 0, so you don't have to worry about it not becoming a function. Flip-flop your x's and y's, so you get x is 3y to the 4th. Now resolve for y. Divide by 3, and then you'll have to take the 4th root. That's where most of you guys left off. Like, oh yeah, it's 4th root of x over 3. But you cannot have a radical in your denominator. You have to rewrite it out to rationalize. Remember, this is the same thing as saying the 4th root of x over the 4th root of 3. Now, I tried to set this problem up to be a very, kind of like an easier way to find a perfect fourth. Because is 3 a prime number? Yeah. Is 3 to the first power the same thing as saying 3?
Yes.
How many more powers do I need to turn that into 3 to the 4th? I would need 3 more of them. I need to turn this into a perfect 4th degree. Right now, it's 3 to the first power. I need 3 more of them to turn it into this. Because the 4th root of 3 to the 4th is just 3. But if I multiply it here, I have to multiply it here. Now they have the same nth root, so I can combine what's underneath the radicals. And the cube root of 3 is how much? Or not cube root, I'm sorry, the 3 cubed.
27.
27. That's why you guys were like, moving. So your final answer should have been the 4th root of 27x over 3. Yeah, Maureen?
On the bottom though, when it says 4 root 3 to the first power, when
Yeah.
you multiply it by something that's a cube root, wouldn't you leave it as 3? Or no?
I did, because what I did here is because this is 4th root of 3 to the 4th, which is the same thing as 3 to the 4 over 4, which is just 3.
No, I mean like when you multiply 3 to the first times 3 to the third,
Mhm.
wouldn't you leave it as 3 to the third?
No, because if you multiply it by 3 to the 3rd, you have a different nth root out there.
Okay, so you just add the.
Yeah, I'm just keeping the radical with it. That way I'm keeping the exact same nth root, so that way my fractional amounts are all going to be the same. What I'm trying to do is create this perfect nth root with a 4 out here and a 4 inside. I'm trying to find instead of finding a perfect square, like we did when we rationalized with square roots, I'm trying to find a perfect 4th without multiplying it out. Without writing this as 3 times 27 to get me 81. I'm writing it in terms of exponents, Because if I have the same exponent here and here, it just drops out and becomes 3. Okay, and I try to put it up with a value that would have been a little bit cleaner to work with. Okay. The other one, yeah.
I have a question about one on the
Can you scroll up a little bit?
Yeah. Which one?
I'm just curious if you can.
When you write that into exponential form, you always put your nth root in the denominator and all the other junk in the numerator. So in that case, it would have just been the quantity 5x to the 7/4. Your nth root goes to the denominator.
Oh.
The x, when it's raised to, goes to the numerator. Does that make sense?
I thought.
That's all I read.
The other one I wanted to look at on the packet, especially as far as solving an equation was concerned, was number 26. I'm going to ask this one a lot today.
Why are these numbers turning out to be so big? On like 25 to 28.
Really? Should have.
I've been like, it's probably, they're probably not that big.
Yeah, having a calculator is helpful. So when we do this, what's the first thing you got to move? The 6. I got to move the 6. So in my calculator, I type in -191 over 32. I hit enter, and I add 6. Now I'm going to get some weird looking decimal. Well, that decimal equates out to 1/32.
That's what I got.
Good.
No, like I didn't even hear this.
Oh, that's fine. Yeah, sometimes the calculators will spit it out that way. I know some of them do, some of them don't. So now you've got that equals x minus 8 to the -5/6. Remember, when you have to undo your exponential powers, you have to raise it to its reciprocal. What's the reciprocal of -5/6? -6/5. So I need to raise both sides to the reciprocal exponent. When I have power to power like this, I multiply them together. -5/6 times -6/5 gives me 1. 1/32 to the -6/5 gives me
No, but then don't you need to, like switch around so it's 1/6?
Nope. Nope. Nope, because when you put that in your calculator, if you have that just in your calculator as 1/32, oh, that sucks. If you borrow someone's near you, maybe.
That we added the ASAP to do it.
If you could only remember your fish, we'd be even better off.
That is actually.
What?
That's pretty good.
Anyway, so when you type it in your calculator, if you had said calculator,
Yeah, that I never
Like
understand
thirsty
that.
calculator? That's what's up.
parentheses 1/32. If you're going to write it like that, raise it.
That word, I don't know how it works, but it works.
Richie's thirsty too.
Was it -6/5?
Richie, can you get our
64. You get 64 for an answer.
Murphy, what did they do before they calculated?
Cry.
They just didn't do this math.
Believe it or not, what that means, again, what that means is that you fix fraction right away, so you get 32 to the 6/5. What's the 5th root of 32? What are 5 numbers that's the same number that goes to 2? So then what's 2 to the 6th? Well, you know what 2 to the 5th is? It's 32 times 2, you get 64.
Oh, that's
Add 8, you get 72. Okay? That's how that one works. I've had lots of questions on that one today.
I'm just so confused about why you don't switch the -6 to be happy.
When you're solving an equation, use your calculator. You don't have to switch anything. The calculator will do the work for you. If you are simplifying, you have to do the work. Okay.
Oh, so if I'm simplifying, I have to do work in the equation and just put shit in.
Yep.
Alright.
Let's see, what was the other one I wanted to look at here? Oh, I remember. Do we have the same basis here, ladies and gentlemen?
Yeah.
I have same bases, different exponents that I'm dividing, which means I have to play the game of war. Who wins? 1/6 or 2/3? 2/3. Now, that's the exact same thing as saying 4/6, correct? So what's 4/6 minus 1/6? 3/6. So it's 1/25 to the 3/6, which is the same thing as 1/25 to the 1/2, which is 1/5.
So I got it wrong, but I didn't put it as 1/5.
Yep, because you can continue the problem. It's not simplified fully. Yes?
How about 12?
Mr. Murphy, how many people did that? May I ask?
Handful?
Mr. Murphy,
Yes, sir.
I feel dirty because you gave me the point at 6.5.
X and negative 6.
Did I? I must have been.
Because he was cheating now.
After that Christmas party.
Yeah.
Me just to get the same wrong answer, she was cheating.
Again, in this case here,
Only 1 week of the wrong
one of the first things that I would do is, since I have the 15 on the outside and I've got 5s as denominators on the interior, I'm going to do all my power to power stuff right off the bat. So I have negative 2/5 times 15 is going to give me x to the negative 6th, y to the 5th, which is y to the 5th over x to the 6th.
I get it.
What I'm doing here is, since these are power to power, I'm taking 1/3 times 15, and I get 5. Negative 2/5 times 15 gives me negative 6, and I just flip them around.
I just ended it.
I brought X to negative because it's happy, even though it was already empty.
I accidentally added 1/3.
What are you mad about? Right here, yelling Murphy. In some countries, it's a 4-letter word.
Yeah.
Just like math is. What's the cube root of 8? 2. What's the cube root of 27?
3.
What's 18 times 2?
6.
What's 3 times 3?
9.
Oh, yeah.
I just put the whole thing in my calculator. Right?
Did it literally spit it out? We have arrived.
That's so inappropriate.
Now, like I've said to everybody else so far today, you've got tons of problems here to look at. You've got the chapter review stuff to go over.
I'm doing.
I'll be here tomorrow morning. You guys have the benefit of flex and whatever, but bring in the decorations for Pete's sake. Yes.
You mean for pizza's sake?
I see what you did there.
Yeah, you liked it. Don't
Can you
act
just come
it.
and show me
You're acting
5?
a fool.
I'm pretty sure, I'm probably got it wrong.
Jay
Same on the
changed
sticker.